Good night, everybody. We're now live. So we're asking that you have your backgrounds all nice and ready. In tonight's episode, we'll be looking at energy forms, page 47 from our science workbook. Darian, could you start off with the first two bullet points on page 47? Okay, Corey, next three bullet points.
What is energy?
Not hearing you, Corey, any at all. We need it to be louder than that. Not hearing you clearly at all. Go again. Really? Go again with that. Radiant. All right, thanks. TC, next two bullet points.
Kinetic energy. Kinetic energy is energy of an object in motion. The energy of the moving car can demolish a concrete wall, a rolling ball. An aeroplane and snails also have kinetic energy. Where are the where where there are forces, there is also stored energy called potential energy. Potential energy is energy an object has because of its position or the state it is in.
Okay. Let me see who's next. Talia, are you there? Could you take the last 2 points on the page?
Okay, sir. Energy constantly changes from potential energy to kinetic energy and back again. For example, when a ball rolls down the steps, its potential energy changes to kinetic energy. Kinetic and potential energy can take many forms, including mechanical and chemical energy.
Excellent. Let's go over. Shernese, number one and number two on page 48. So mechanical energy, hold on, mechanical energy has to do with moving objects, okay? All right,
Yes.
go ahead, go ahead. Thank you. Hold on. Thanks. Thanks. Let's. Mr. Allen is there.
Yes, sir.
All right. Go ahead from if current flows.
If current flows through a substance, that substance is a good conductor of elec- electricity. Most metals are good conductors of electricity. Car- Carbon is a good conductor, although, although it is a non-metal
So
substance.
there are some substances. Hold on. There are some substances that are metallic, and others that are not metallic. Okay. So
Yes,
most metals are good conductors. Once you think of metals, you're thinking of something that will be a good conductor of electricity, right?
Sir.
However, they are saying carbon is a good conductor, although it is a non-metal. All right, continue, sir.
substances which allows little or no current to pass through are poor conductors. For example, glass and wood. Substance which allows no current through are conductors. Non-conductors are called insulators. Connect wires are usually with insulators.
All right, it says electricity can be dangerous. You need to know how to use electricity safely. Never. What is the word?
Never.
Never.
Never use electric appliances when your body is wet. Never stick anything except a plug into an electrical outlet. Never plug too many cords into one outlet. Never fly kites
Your
near
power
power line.
lines.
All right, pay attention to this. Sometimes the girls will wash their hair. They come out of the bath dripping wet, take up the hair dryer and turn it on to blow dry their hair. You are working for a good shock, if not your own death, right? You need to be dry. All right. So it says now, note electricity
Yes.
supply, for example, in our homes, factories, and on the streets is driven by generators in power stations and not by batteries. Batteries, though, provide electricity. For example, in motor cars,
Vehicles.
flashlights, and clocks. Now, so those are different forms of energy. Different
Energy.
forms of energy. Now we move over to energy sources.
Course.
Yes, go ahead. Yeah, so tell her that she has to watch instead.
Excuse me,
Right.
sir.
Go ahead.
Sir, when we were reading about thermal energy, sir, you were telling us about the snow monkeys in class.
Yes. So
They have
we
your
had done
thermal
some
energy.
right. We had done something in class talking about thermal energy, right? Saying that this uh source of energy is available to a lot of individuals across the world, and they use it to their advantage, right?
Yes, sir.
So there are countries where they use that heat energy to keep their houses warm and so on. And the snow monkeys would be an example of a group of animals that use thermal energy to their advantage, they would not be able to live high up in the mountains of Japan if it had not been for those hot springs. Okay?
Mhm.
All right. Um, let's go to energy sources now. Go ahead. We're not hearing you. Derived is called biomass. What is it called?
Biomass energy.
Biomass.
Yes. All right, stop there. So let's look at some of the sources of energy again. We have no, somebody has me on speaker, and that's going to create a problem for the rest of us listening. So we have batteries, fossil fuels, solar cells, panels, weather system, the moon, atoms, biofuels. We have nuclear energy, tidal energy, geothermal energy, chemical energy, hydroelectric energy, and so on. We also need to remember that some will be renewable, others will be non-renewable.
Non-renewable.
All right. Now let's look at heat transfer. It says if you stand near a fire, heat enters your body from the surroundings. If you are outside on a very cold day, heat escapes from your body into the cold air around you. There are three ways by which heat can be transferred: by convection, conduction, and radiation. What are the three ways we transfer heat?
Convex.
Convection, conduction, and radiation.
All right. So let's go now to convection. Talia, read that for me, please.
Convection. Convection is a transfer of heat energy in fluids such as liquids and gases. The particles in fluids are free to move around. Heated particles become lighter and rise up, while colder particles sink and take their place. This results in a circulating flow called a convection current. Convection helps to heat many homes. Our food can be cooked in water because the water gets hotter by convection. Convection also has a part to play in weather systems. When the land gets hot, it heats the air above it. The heated air rises because it expands and becomes less dense. Cooler air falls to take its place.
All right. Conduction. Corey, do you want to do that one for us? particle. All right, good. Radiation. Let's go back to TC. TC,
Yes, sir.
read radiation for us.
When you are outside in the sunshine, you feel hot. The heat from the sun comes to you without heating the air. Radiation is the means by which energy travels across an empty space by electromagnetic waves. Heat and
Electromagnetic.
electromagnetic waves. Heat and light are Heat and light energy are transferred to the earth by radiation. When radiation touches an object, it makes the object's particles move faster. When the object becomes warmer, when the object microwave oven heats food by radiation. Radio and television programs also reach us by radiation. Other types of radiation are sunlight, radio waves, and X-rays.
Okay, it says note. Substances such as gases, liquids, and solids expand when heated and contract when cooled. Freezing point is the temperature at which a substance turns from liquid to solid.
Solid.
And then melting point is the temperature at which a solid turns to liquid. Boiling point is the temperature at which a liquid becomes a gas. All right. So we have done that little bit of reading there. So we should be able to answer these questions now. We're going to go through as quickly as we can. So let's see. What is energy? Anybody? Energy is the ability to do work. To do work.
Work.
All right. Name some forms of energy.
Thermal.
Thermal. Yes. What about nuclear? All of tidal. All of those. Right. All of those are forms of
Energy.
energy. Okay. It says give the name of the Earth's main source of energy. What would that be?
The sun.
Sun. Name two ways by which living organisms benefit from this. Mm, I I wasn't going to go vitamin D yet. Good. So we get what from it?
Heat.
Heat. But we also get what? What plants need for photos? Right. So we get heat and light for what? Keeping us warm and for photo
Synthesis.
photosynthesis. All right.
Synthesis.
So
Yes, sir.
that helps us by giving us food and keeping us warm. Go ahead, Mr. Ali. Let me double check on something here and click the YouTube link. Let's see. Link, YouTube, copy. go over now to WhatsApp. Hold on a second. Let's look for her. I'm gonna send it out in the WhatsApp group again. Send. Tell her to double click on it now. Tell her that I sent the link in the WhatsApp group. She can look at it. All right. Okay, Roger, hold on. Okay, I'm listening to the WhatsApp the thing on YouTube now. Somebody's typing and it's playing. Okay. All right. So going back to that one again. So we were saying that we get light and heat. Number 3, what happens to energy from electricity when you turn on an electric lamp? Shanice, go ahead. Okay, so we have a change to light and heat. Okay. How does it? Someone is still typing. Yes, it does. You know, if I find out the person who it is, that's a good night, sweet prince. All right, let's go again. So how does electricity reach your home? So I'm hearing Shirley saying that they are generators, right? And then I'm hearing electrical lines. So take this for example, the nearest generating plant to school would be in Old Harbor Bay. They have a JPS power plant there. And then
Yes, sir.
we are connected to that power plant by electrical lines. Okay.
Yes, sir.
All right. So this is why sometimes if we have a hurricane and the lines get broken miles away from where we are without light because we would have lost our connection. All right.
Yes, sir.
Why is electricity? Look at number 5. Why is electricity the most versatile form of energy?
So because it can be generated or transmitted to where it is needed and converted into other forms of energy.
All right. So I like that response. So one, we can generate it. We can do what?
Transmit.
Transfer. We can convert it to what we need. Sometimes we convert it to sound in terms of music and or TV. We can convert it to light to watch the TV, to look at a projector. We can convert it to heat to cook our food, to keep us warm. So electricity is very important. Okay.
Yes, sir.
We use it for security. We use it for security. If a thief is breaking into our car, we have a horn that works from the battery and it begins to make noise, telling us that hey, somebody's trying to take the car away, or somebody's trying to break into a house, or something like that. True?
Yes, sir.
Okay. Well, yes, Alan. All right. Well, she has to catch the replay then because I am listening to it right now and it's working fine. Okay. It says, why do you think electricians wear rubber type shoes when climbing electric poles? Okay.
Sir, it is a insulator, sir.
Very good. That's the scientific response I want. So the rubber type shoes would be what? An insulator. So if there is electric current moving along the pole, it's supposed to separate them from the what? Electric current.
Pole
All right.
current.
All right. So distinguish between kinetic energy and potential energy and give two examples of each. What is kinetic energy and what is potential energy? So I like to say it this way. I agree with you. I like to say kinetic energy is energy in motion. So it something is happening. While potential energy is what then? Okay. So it's not moving or it's simply stored energy. Okay, let's look at an example of kinetic energy. I want two examples of kinetic energy. One more.
The girl using a jump rope.
Jump rope, yes. A ball rolling or water flowing. All right,
So a
those are
car moving.
examples. Car moving. Stored energy or potential energy.
Sir, a car is sir a car in a parking lot.
Okay. What else? Okay. So I have food.
Yes, sir.
If
Food.
the food has what? Chemical energy.
Chemical.
Chemical energy is a form of what? Potential energy.
Potential.
I will have to take that energy and then burn it at a cellular level um for the energy to be released, and we use the energy to do work. Okay, so food would be
Yes,
an
sir.
example. And the stone at the top of a hill that's not moving, that is a form of potential energy also. All right. Number 8.
By driving off.
All right. Give me a second. Let me find something for you. Um, don't move just yet. Hold. All right. I'm going to send a link to you afterwards. With some videos that we can use to review some of the stuff we have done. Let's go to number 9. Heat is transferred by each of the following. Conduction. Anybody? Tell
Sir,
me
like when it
what's conduction. Okay. And it's what type of object?
sir mostly metal, sir.
Not mostly metal. Good example would be metals, but let's no, come on. Conduction is associated with what state of matter?
Solid.
Solids. So conduction describes heat transfer in solids. Okay. Conduction describes heat transfer in solids. What's the next one? So what is convection then?
Sir, sir, when heat is passing through water or gas.
Very good. So convection describes heat transfer in what? Liquids liquids, and gases.
gases.
Okay. What is radiation? Yes. Anything else?
It
Anybody else?
passes through the it passes through air without warming the air to user.
So it passes through. It passes. Okay. So it can pass through a medium without heating that medium. All
So
right.
it goes to a vacuum.
Vacuum. So examples would be uh what microwave and how the sunlight
Oven.
reaches the earth. Okay. Number 10. What role does convection play in weather systems? Yes, and
Say the air rises.
good. And then what happened? And then cool air comes in to fill the space. And then this uh, leads to a cycle of wind. So as the hot air rises, then cool air comes in and we have a convection current there. Okay. Sometimes we also have what they call convectional rainfall, right? And we do that. We have spoken about that in social studies. Describe the
Yes,
difference
sir.
between an insulator and a good conductor of heat. Not hearing these people, they're very muffled. Very, very, very muffled. Not hearing at all. Okay, that's fair. Mm-hmm. That very good. All right, so let's look now. It says name three materials that are good conductors of heat.
Turn off the camera.
Metals. What else? Water, carbon. All right. What about insulators? Three insulators. Wood and
Rubber.
plastic. Anybody else?
Glass.
And
Glass.
Rubber, sir.
glass, rubber. Okay. Why do many pots, cooking pots, have wooden handles?
So yes, sir.
So the wood is acting as an
Insulator.
insulator. Okay. What do you
Yes,
think
sir.
would happen when a hot piece of metal is attracted to a cold, attached rather, to a cold piece of metal? Okay, so we would have heat transfer by what process?
Conduction.
By conduction. Why would fossil fuel be considered a non-renewable energy source? Okay. It cannot be replenished easily. Usually, it would take more than 30 years to do so. Okay. All right. I think that the other things there you can answer on your own. Let's see what's on the other side of this page. All right. Let's go down to 18 to 25. All right. So 18, 18 to 25 now. Hold on a second. Give me a chance. Okay, yes. So a television can change energy into light, sound, and heat energy. The energy that moves machines and other objects is called
Mechanical.
mechanical energy. Energy cannot be made or destroyed, but it can be converted. Plastic is a non-conductor of electricity. Chemical energy is a kind of excellent. Plants convert light energy from the sun into excellent. Energy derived from burning wood is called biomass energy. The kind of fuel formed from dead organisms is known as
Fossil.
fossil fuel. All right. So we're gonna stop there, guys. I think we have touched enough. You can answer the other questions and we discuss them in class or in lessons, but we can stop here. In the next episode, we will be looking at nutrition. We'll be looking at nutrition.
Trisha.
Nutrition.
Read up on this so that we'll be able to answer the questions tomorrow. Before I go, I have to remind you that next week, hopefully next week will be mock exam 4. We need to get our high scores then so that we can ensure we can get the prizes at our what church service. All right. So you need to make sure that by that time you are getting your hundreds and your 90s so you can be duly recognized. And the same thing happens for our graduation. So if you do well, then you will be recognized also. All right. Have for yourselves a wonderful evening. Remember to study up and get ready for school tomorrow. All right, guys. All
Yes,
right. Take
sir.
Yes.
care.